Hello and welcome to the Daily Space for today, January 29th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. I am coming to you from a completely different location than I normally come to you from. This is because I am currently out in Tucson, Arizona, where I am at the headquarters of the Planetary Science Institute. I am out here this week to find new stories to bring to you, to find new ways to collaborate in citizen science, and to just generally try and make the world a little bit more scientific of a place. Now, this does mean that you're going to get perhaps a few more technological hiccups than normal. I am just using my laptop screen, which means everything is this big, but that's okay. We'll make it work as we always do. Now, all because my monitor is small doesn't mean I don't have big science to report. In fact, today I feel like we finally have not only a fully operational nation, but a fully operational science community. The amount of press releases that came across my desk was something to behold, and it was a beautiful something to behold. So in today's first story, we have a tale of galactic astronomy. In this case, we have the beautiful release of 5,000 nearby galaxies that have been observed during the first 3 years of a program, and here I have to read it off my screen, called the Mapping Nearby Galaxies at Apache Point Observatory program. So this is the MANGA program, and this is an add-on to the Sloan Digital Sky Survey. The Sloan Digital Sky Survey has been working for over a decade now to systematically observe stars, galaxies, anything nearby, trying to understand the structure and composition of our galaxy and of the universe around us. This is one of the 3 programs that is part of the 4th phase of the Sloan Digital Sky Survey. And what they're looking to do is observe 10,000 nearby galaxies. And using this data, and to get the numbers straight, this is 4,621 galaxies that are all now publicly available via the 15th data release of the Sloan Digital Sky Survey. What they're looking to do here is allow people to understand in fine detail the spectral composition of the light coming from these galaxies. They are using what's called integral spectrometry, which is much harder to say than it should be. This essentially means that they're observing these galaxies in a whole variety of different colors to be able to say very carefully, this part of the galaxy is moving towards us, this part is moving away from us, to look at color differences that represent temperature differences. This kind of data is going to allow us to understand these galaxies in levels of detail never before seen. And it's just pretty. It's always good when our science can also be beautiful. Now, continuing to further extremes in our universe, there is hints that we may finally have an answer to a whole bunch of big questions about how our universe has formed and evolved. Some of the things that you may have heard us talk about previously here on the Daily Space are that there are some contradictory observations out there where when we measure the rate at which our universe is expanding in the nearby universe, and when we measure it in the most distant, earliest moments of the universe, we get 2 disjointed sets of numbers. And it's long been confusing as to whether these observed differences are due to not fundamentally understanding something about the physics of how our universe is expanded, that perhaps there's something wrong with how we measure distances. There's been a whole lot of questions about even just, are there observational issues that we don't fully understand? Basically, why is it that we get 2 different sets of numbers? Well, that answer that it could be something funny with the physics appears to be the new correct answer. Astronomers using data coming from the XMM Newton telescope, Planck Observatory, and the Chandra X-ray Observatory have combined their resources to do a new study of quasars, objects that have black holes in their center that are actively feeding on gas and dust and the occasional star, and are some of the most luminous objects in the universe. By observing these quasars at a whole variety of distances, which puts them also at a whole variety of different times, because light takes time to get to us, they're able to measure how our universe has expanded over time and what the influence of dark energy has been over time. Now, the reason they're able to do this is they think they have figured out a way to use quasars as a new form of standard candle. What a standard candle is that thing that always gives off a standard amount of light. You may have read a light bulb box before and had it talk about how many lumens, how many candles of light it gives off. This later became a function of how much power does it give off, what's the wattage. And when it comes to stars, we often talk about how stars like Aurora variables, Cepheid variables, are standard candles where we know they always give off the same amount of light. And by measuring how bright they appear, we can calculate their distance the same way when you step off the curb and look both ways at night. If you see that lone motorcycle headlight and it appears quite faint, you know it's probably off in the distance. But if it's very bright, you know you probably should get out of the street because you're about to get hit. Our brain automatically is able to do these calculations. And we as astronomers have figured out how to mathematically observe the apparent brightness of an object and using its known actual brightness to calculate those distances. Now, the standard candles that we've used to date have been things like type 1a supernova, variable stars of certain kinds, and these different techniques leave large gaps in the parts of the universe that we're able to observe. We also use data from the cosmic microwave background to get at the expansion rate of the universe. And because we didn't have anything to bridge from the nearby supernova-filled universe to the most distant first moments of the universe, we couldn't make sure that something cool didn't happen between those two different points in time. Well, quasars, because they're some of the most bright objects in the universe, we can see them, the nearby ones and the most distant ones. Now, we live at a point in time when there's not that many quasars nearby, but we can bridge from where we are here to quasar systems that have had supernova and thus all the way out to the beginning of the universe. And new data that bridges all of these different distances seems to indicate for the first time ever that dark energy, which we thought was constant with time, may not actually have been completely constant with time. Now here, I'm actually going to read to you what it says in the press release. So they're actually saying, these quasars are observed back to times about 1 billion years after the Big Bang. So we're not going all the way to the first moments, but we're getting to 1/13 of the age of the universe. The new results show that dark energy's effect on the expansion rate in the early universe may have been different from today. So this tells us that our expansion rate, which we now know is accelerating, may not have been accelerating at a constant rate across all of time. So the math describing our universe just got way harder. I am, for one, very glad that I already have my PhD, because that is math I do not want to have to solve. And the universe is a whole lot more interesting than it was yesterday. So this is a story we're going to continue to follow, and I, for one, am really looking forward to getting my hands on these papers. I will share the paper with the chat. I haven't had a chance to read it myself yet because this is a press release that came out today. But we can all share in learning about this discovery together. Yeah, Veronica, math is a thing. So this is by far the coolest story of the day. Now, going on to an actually literally cold story. We have a new press release coming to us about the Kuiper Belt. Now, one of the things that's interesting about this particular press release, and I'm going to have to look up more details about this, is generally you hear that band of icy objects that Pluto is part of, that New Horizons has been flying through, referred to as the Kuiper Belt. But in this particular press release that is coming to us from the National Astronomical Observatory of Japan, they refer to it as the Edgeworth Kuiper Belt. And so there's some history in here that I need to look up and learn more about. Sounds like there just might be someone who isn't getting his proper due or her proper due. Anyways, what they're talking about in this press release, and this is an artist's rendition that you can see right here in this image, while we've been able to find tens of kilometer, hundreds of kilometer sized objects out in the Kuiper Belt, what we haven't been able to observe until now is the 1 to 2 to 5 kilometer sized objects that would be the initial building blocks of planets. Well, in new observations, they are saying that they have discovered a new object that is 1.3 kilometers in radius, so 2.6 kilometers in diameter. This is a distance you could walk probably in an hour. And this tells us that our theoretical models of the size distribution of objects out in the Kuiper Belt is probably true, that these tiny objects that build up to form, well, the Plutos and Sednas of our solar system are out there. So this was found using the OASIS, the Organized Auto Telescopes for Serendipitous Event Survey team. They used 2 small 28 centimeter telescopes on the roof of a school on Miyako Island in the Okinawa prefecture. And they monitored 2,000 stars for 60 hours. And in the process of reducing that data, looking at all these stars, in that data, they just happened to find this 1.3 kilometer icy object in the outer solar system. So one more bit of ice is now identified, and we're getting closer to finding all these tiny things that we know should be out there. We just haven't been able to see because they're too tiny and too far away. So this is cool. And in one more piece of news, I am sad to report it is warmer on Mars than it is in many cities in the United States today. If you are one of the people who is suffering from the Earth's polar vortex, I am so sorry. We will be discussing the science of them in this Friday's Astronomy Cast, but for now, know that if you went to Mars, it would be warmer. Not a lot warmer, but it would be warmer in the equatorial regions. Anyways, this is a story of Mars Curiosity out on that nice warm desert world, or really, really cold, but not potentially as cold as you, desert world of Mars. The Mars Curiosity rover has been working its way up the Vera Rubin Ridge and has finally crested that ridge, doing its own small degree of mountain climbing. This is one of the things this rover was built to do, and now continues its journey out towards some clay deposits between it and Mount Sharp. This particular rover, it has this fabulous nuclear-powered system, radiothermal generator, that allows it to last longer and hopefully do more in terms of heavy driving than we thought we were going to be able to do with spirit and opportunity, and it was put in a place where we know that there was water in the past. And as it goes and samples all these different minerals, it's giving us a steady stream of new insights into what Mars is today and what Mars was in the past. These clay samples it's now headed towards, well, this is the kind of stuff where today no life, but we don't know what might have been there in the past. And curiosity isn't set up to go looking for fossils, but it can tell us what is the mineralogy of these clays and just what is, well, a little bit more of the chemical history of the red planet. So congratulations on your mountain climbing curiosity. Keep going. Just keep going. Now, I don't have much to keep going with today. That does bring to a conclusion the news that I have for you. I will now answer your questions. Just please go ahead and at me in the chat. And while you're typing those questions in, once again, this is The Daily Space. I am Dr. Pamela Gay, and this is a production of CosmoQuest. We are brought to you by the Planetary Science Institute and Youngstown State University. You saw Annie yesterday, and I am so grateful for her filling in while I was traveling out here to Arizona. We are here to put science in your brain, and we are slowly getting CosmoQuest.org brought back up to speed with an entirely new design. We don't have our citizen science projects back. We're working on it. We're doing a complete update to the front end and the back end. And we'd ask for you to please continue to bear with us just a little bit longer. So thank you all for being here, and let me see what questions there are in the chat. Thank you, Bill Nash. Thank you so much for the sub. Can we get a shout out for Bill Nash, someone who's one of the mods? Bill Nash is another one of our science streamers here on Twitch. He does photography. He has amazing street performer photographs, astrophotography, and you can learn a lot about image processing from watching his streams. They're often in the evenings, and it's just eye candy. I highly recommend checking it out. So yeah, I see a bunch of the TKF emotes there in Jandreloon's message. Oh, that'll be amazing, Bill Nash. I can't wait to see. Questions. Yeah, I'm seeing the conversations about all the wind chill. The wind chill right now is horrifying. St. Louis, which I normally will hit like -10 worst case every few years, currently has a weather advisory for wind chills of -25 to -30. I feel somewhat guilty to currently being here in Tucson where it's in the 70s. I'm speaking in Fahrenheit. So I'm in the mid-20s centigrade here, and it's like -30 centigrade back home. So everyone take care of yourselves out there. It's kind of brutal. So Hanny is wishing good travel. So far, so good, and is saying, will this change any ideas of what we think dark energy is or how it is produced? I don't know yet. I need to go read the paper just like everyone else. But it's good to know that we now at least have a hope of bridging between our understanding of the early universe and the current universe. Yeah, it's dangerously cold out there. How was Binary Ablaze not a mod before? Wow, okay. There, you've been modded by multiple of us. So do we have any questions out there? I do have a hard end of 11:30 Mountain Time, which is 1:30 Eastern today. I don't actually make my mods fight it out. So Zine is asking, regarding the new Kuiper Belt object, have they determined the orbit yet? I assume they have in general. Before you can publish your information on these objects or estimate how big they are, you really do need to have your orbit nailed down. If you are looking at a really big object that's super far away, it will look the same as a smaller object that's nearby. So to be able to say it's 1.3 kilometers across, they really need to know the distance to it. And to get to that, you really need to know the orbit. Great emote use, Noel. Great emote use. So Silvershot is saying, what is the current understanding of how stars move around in a galaxy? They all spin together like in a dish or something. Not quite. It really depends from galaxy to galaxy what's going on, because galaxies are formed in two different ways. The biggest galaxies that formed earliest in our universe were formed through the collapse of a giant mass of gas and dust. And they ended up forming an ellipse of stars that are in a random distribution of orbits around a center point. In galaxies like our own Milky Way, you had a bunch of smaller systems that came together. And so you'll end up with everything in a disk, but the orbits of individual stars might be highly elliptical, might be very circular going around the galaxy. And while the majority of objects will all be going in one direction around that galaxy, there are going to be those interloping stars that, for a variety of different reasons, are going in completely the wrong direction. So there's general trends in how galaxy stars might be moving. But star to star, anything is possible. So Hanny is asking, would it make any sense to get an infrared telescope at Neptune's orbit to find all the small KBOs? Yes, but it would be super expensive and hard to do, so it's probably never going to happen. So Paranor is asking, can you say anything of how the dark energy news will affect the calculations of the universe's age? I think our understanding of the age is fixed because it's determined from the cosmic microwave background and different physics. What this will change is our understanding of how the universe is expanding over time, and it's potentially going to add an extra term. I still need to read the research paper. But in a car, if you put your foot on and your car accelerates at a steady 1 mile per hour for 60 seconds, you'll go from 0 to 60 continuously. Now, imagine if instead you put your foot more and more down on the pedal so that the first second you are accelerating by 1 kilometer per second. The second you're accelerating at 2 kilometers per second. So here you have an acceleration of your acceleration. We're looking at having that extra kind of a term that's really going to make the math ugly, but we're looking at having that kind of an extra term added on. So, Hanny is asking, are there any stars that are in polar orbits around the galaxy? Yes. Since our galaxy grows by eating other galaxies, we have stars in pretty much every imaginable orbit. It's kind of awesome that way. Hanny, at least we have all sky surveys. Sometimes that is enough to at least get us started until we figure out how to afford to put big telescopes all the wonderful places we want to put them. One of the problems with getting a telescope out to Neptune is you have to change your velocity once you get there. So you need to send something there at a rate that gets it there before you die. That's a good goal. And then have enough fuel still on board that it's able to slow down its passage outwards to match the orbit of Neptune and get into an orbit around Neptune. And that extra fuel really complicates things. This is why doing a flyby of Pluto is hard, but totally doable. But actually getting to Pluto, that's probably not going to happen in our lifetime. That was a very pessimistic statement, but I stand by it. So Silvershot is saying some stars stars are retrograde. Yes, there are stars that go backwards. We even have asteroids that go backwards in our own solar system. Collisions, interactions, all these kinds of different things can send objects in all sorts of random directions. So because things interact with one another, things sometimes get slung off in completely weird ways. It turns out reality is consistently more creative than the human mind. And that is what makes science so cool to do. So that really does bring me to an end today. I am running out of time. Thank you all so much for being here. Thank you for the subscription, Bill Nash. Thank you all for the support. This show is sustained by you. We have a Patreon, patreon.com/CosmoQuestX. If you support us over there, you will get great benefits. If you support us with a subscription, you will get great emotes. Can I suggest doing both? More seriously, we are literally supported by you through a combination of things and stuff. We don't have the massive NASA grant that got us started. And as we work, like so many other scientists, to rebuild our programs, we rely on you to keep the science flowing. Every donation really helps. This is how we're paying Annie and all the other people around here. Every bit truly does matter. So if you want to support science, well, be the change you want to see in the world by throwing change at us. That's the begging part of the show. Thank you all so much for being here. I am going to try and figure out how from my laptop to run the credits, which is surprisingly hard on a laptop monitor. And after I run the credits, I am going to find someone to raid. If you want to suggest anyone to raid, I am totally up to suggestions. It looks like Oh Bother may be going right now. Thank you so much for the bits. I can't see who it's from right now, but I can say thank you. And I'm currently trying to get the credits to fit on screen. Everything resized on my laptop. So awkwardly, I am about to switch over to the credits, and thank you all for being here, wherever you are in the world. Have a fabulous morning, evening, afternoon. Stay warm, and if it's clear and warm enough, don't forget to go outside and look up. Bye-bye.